this, let's look at the graph of f again. Now, as x gets infinitely large, or as we go along the x-axis, note that the graph of f is bending slowly downwards towards a height of 2. Now, if a graphical argument is not enough for you, take a look at this chart based on the function values of f. As x gets larger, f gets closer to 2. Now, mathematically, this means that the limit as x approaches infinity of f equals 2. By the way, the limit as x approaches negative infinity of f also equals 2. As we travel left along the x-axis, the function approaches the same height. When I was explaining the last example, I said that x was getting infinitely large, and we translated that mathematically as the limit as x approaches infinity. Now, this type of limit is called a limit at infinity. If this limit exists for a function, then that function possesses a horizontal asymptote at the height given by the limit. Now, that's a lot of gobbledygook, but it's very simple in practice. Limits at infinity are very easy to calculate. All you have to do is compare the degrees in the numerator and denominator of the given function. By the way, the degree is the highest exponent. So if we take a look at f again, we'll notice that the highest degree in both the numerator and denominator is 1. Because remember, if we don't write a power, it's inferred to be 1. Now, in this case, the degrees of both the top and the bottom of the fraction are equal, and therefore the limit at infinity of this fraction is going to simply be the coefficients attached to those highest degrees. Again, sounds like a lot of gobbledygook. We just take the coefficients of those x terms to make up the limit. Therefore, the limit will be 2 over 1, and we say that the limit as x approaches infinity of 2x plus 1 divided by x minus 3 is 2. And remember, we already know from the graph of f that the horizontal asymptote is 2, so it checks out. Now, what happens if these degrees are unequal on the top and bottom of the fraction? Well, if the denominator's degree is higher, then the limit is 0. But if the numerator's degree is higher, the limit doesn't exist because it's infinity.